Hello and welcome everyone. Now we are going to learn about the logical gate symbol. Well, what does it mean? So let's get into it and let's learn something very exciting that I wish to teach you. So there is a organization called as IEC, as you can see here, International Electrotechnical Commission. Well, as the name suggests, it's a technical commission. Well, as I have already mentioned here, they make symbols of logic gates. So they provide us the symbols that we have to use for our logic gates. So it means they provide the symbol like we have seen the symbols in resistance, capacitor, and all that thing. So they provide that for the logical gates, logic gates. Okay, but the interesting fact here is that they are rarely used despite of their status. It means we don't use that IEC standards, we use simple standards, so we use it our way. We use it our way. And that's not just my word, that is the word around the world. So you just know that symbol so that you can officially call them by that symbol or can study that by their symbol. It will not make any difference, of course, but just for the sake of learning, we will go through that thing also. Alright, so let's begin with the gates. Well, before reaching to the gates, I would like to tell you that what are inverting circles. Well, so many times you will see that there is something like this and a circle here. Well, I made a NAND gate technically, its name is NAND. But the main thing is what it is. Actually, it's a combination of two things, not plus and. So the symbol for the AND gate is very simple, just like this. These are the two inputs and this is our output. And when you place the inverted circle or inverting circle, that means the NOT gate operation. So whatever the input is, like let's say the output is going to come 1. So after reaching to the inverted circle, what will going to happen? It will going to be 0. So it will going to invert that simply or just reverse that for simple meaning. Alright, so what we are going to study, well, we can take any number of inputs, any number of inputs and can have any number of outputs. But for NOT gate or inverted gate that we are going to study also, NOT gates, we have only one input and one output. So that's the whole story of it. Well, I hope you have got these things, and with all that said and the note part that I would like to mention it. So we are going to focus on two input system. Why? Well, there is not specifically any reason. You have to start with any one or two or three. So we are going to start with the two. It will work similar logically for any kind of the input that you wish to take. Okay, so it's time for the truth tables to learn. And in the truth table, first thing first, so we are going to take two inputs and one output. So we are working on that thing. Well, how we will work in the NOT gate? Well, we will see that. Okay, so let's start with the NOT gate itself so that we can clarify the confusion right here, right now. So NOT gate. Well, NOT gate is also called as inverter. Not that inverter one that we have learned in the previous section. This inverter means that it inverts the result, like our answer is on, so it will give us off. If our answer is off, it will going to give us on. So it always works in that way. Well, the traditional symbol for that, let's learn the symbol obviously. So traditional symbol that we all use, if you are referring any book of digital electronics, you're going to see these symbols only. So the traditional symbol is this one, just line, triangle, and the zero, and this is the output. So basically this is the input point and this is the output. So we have one input and one output, and now let's get into its truth table. Well, before reaching to the truth table, just for the respect and regard of the IEC standard as we have seen here, so its official symbol or IEC symbol, well, we are also going to learn that one. So what is the IEC symbol for that? Well, the IEC symbol is seemingly like this. So this one, and we write is equals to 1. Well, that's a symbol. You cannot question it why it's like that and all that things. It's just like this. And the inverter here, our inverted circle that I mentioned up here. So this is the inverted circle as I mentioned, and this is the IEC symbol for the NOT gate. Interesting, right? Okay. Now we are going to learn its truth table. So let's quickly make its truth table. Let's make it working. So we have input, and surely we are doing work to get the output. So as we have only one input and one output, one in and one out, so what we are going to do here is for the 0 we are going to get 1, and for the 1 we are going to get 0. Well, now I think you can relate with the word inverter. That's what it means actually. The inverter means this one, and this is our TT or truth table. So this is our truth table, and we learned the entire thing about the NOT gate. Now let's proceed to the next level where we are going to learn about the AND gate. So let's learn about the AND gate. Well, one last thing I would like to mention here, that you can write it like this: Y is equals to A bar. A is output, bar means change or invert. I am writing invert, and Y is output. Well, this is the way of writing it. So I'm telling you the mathematical part alongside. If you remember, we have already studied that in previous sections also, but I'm mentioning it again just for the sake of the revision. Okay, now we are ready to learn about the AND gate. So what is AND gate? Well, excitingly, AND gate is logical multiplication. So what is the meaning of the logical multiplication? Let's see. So here what we have is logical multiplication. So what in the logical multiplication we actually do? Well, Y is equals to A dot B. This is the fundamental result that we do have. Y is equals to A plus B. This is our formula part. And now it's time to get through its truth table. So we have inputs as usual and output. Well, before going to input output, let me also draw its symbol. So its symbol is like this, and obviously is the traditional symbol that I am drawing on the left side of it, and on the right side of it I'm going to draw its symbol that is given by IEC. So the IEC symbol is something like this. There is a box and we write the ampersand, and well, you can also call it and, sometimes people call it and, but it is ampersand as per the language of the computers. So this is the thing. Well, input and output. This is output and this is input, and same, these are the inputs, two inputs we have here and one output. Okay, with all that said, let's make our table done. So let's divide it into two parts where we have A, B and Y, so that we can also relate it with our formula part. Okay, so what can be the possible result for that? Let's see. So here we have 0 0, both are off, one is off, one is on, one is on, one is off, and both are on. Well, you can call them on, off, or 0 1, whichever way you like it. Now 0 multiply 0 going to give us 0, 0 multiply 1 is going to give us 0, 1 multiply 0 is going to give us 0, and finally this is going to give us 1. Well, we have already studied that in detail in the previous section, so I'm not going to take that again and again, but I hope that you have revised the end gate from here right now. Now let's proceed to the next one. The next one here that we have is OR gate. Well, I'm making things a little quicker because we have already studied that, and it will give us more time to study the gates that we have not studied. Nice idea, right? Okay, so let's first start with the symbol. So the symbol, traditional symbol, is like this. So this is input and this is as usual output, and this is traditional symbol. Now it's time for the IEC symbol. So what is the IEC symbol we have? Well, we just have to make it like this way, and one output greater than equal to more than 1 actually. So this is the IEC symbol. Well, that's all we need to learn. And what does it actually mean, the OR gate? Well, it's logical addition. So it's logical addition. In simple words, we write it like this: y is equals to a plus b. So this is gonna be our formula. Now let's work on a truth table. Truth table. We have y, a and b. A and b are inputs and y is our output, as we know. So let's make it happen. Okay, now let's fill it up. Both are off, one is off, one is on, one is on, one is off, and 1 1. Now logically adding, we get something like this. On putting the value, you can easily figure out that how I did that. Just add them. That simple. Why it is not 2? Well, we have discussed that last time in last section, that why it's not 2, because on means on. That's what it meant. Well, okay, that's all for the OR gate. Now to the next level of it. Next level is our NOR gate. I think we have not studied the NOR gate previously. We have studied the XOR gate. So it's time to study NOR gate. Starting the symbol, NOR gate, as the name suggests, it's somewhere the OR gate. So this is the exact symbol. If I leave it like this, this will going to become OR gate. If I add this circle, now it's gonna called as not or NOR. This is traditional symbol that we are using frequently. And now time for the IEC symbol. So in the IEC symbol, we use something like this. So there is a box and it's greater than equal to 1, that circle part, and this one. That's it. That's all we have. This is the IEC symbol for that. Now what is its logical formula or logical definition? Well, it's not or logically. What does it mean? Well, Just invert the result, that's it. So on the formula part, if we try to write it as, that will become y is equals to a plus b. So this is the formula for the OR gate, and now the twist comes in when we put the bar. So this is our result. Now let's draw its truth table. Let's work on its truth table. So in the truth table we have a, b and y. A, b are our input and y is finally gonna be our output. So let's make it up. No, it's not the background music, it's my voice. Okay, let's do it. So it's 0 0 0 1 1 0 1 1. Well, you can sometimes sing the song. I think you will not mind. So the answer for the OR gate is gonna be 0 here, but now we are going to write the 1. Let me change the color so that we can see. So it's gonna be 1, it's gonna be 0, it's gonna be 0, and it's gonna be 0. That's simple. Well, as we have done in the OR gate, I think you have noticed it. 0 1 1 1, just invert it. So 1 0 0 0. This is what we have done in NOR. Let's see. Now you can see that, right? So it's very simple, just using the NOR gate. Now it's the time to learn about the next gate, which is our XOR gate. Well, this is the second last gate, so don't worry, we are almost on the shore of it. So what we are going to learn is XOR gate. Well, this is the XOR gate, starting with the symbol. The symbol seems something like this, so we need to draw it carefully. It's like this. Okay, we are done. And obviously this is a traditional symbol. Now it's time for the IEC symbol. So the IEC symbol seems something like this, the box, and these two lines is equals to 1. We write in this case equals to 1. Now this is the output and these are the inputs. So these are the inputs and this is our one output. Same for this output and inputs. Okay, let's come up to its definition part. Well, its name itself is a definition. This is exclusive OR. Well, what does it mean? Well, in this case, I am changing the trend and we are going to learn the truth table first, then we are going to make its formula. Well, let's see that if you can figure out the formula by just looking at the results. So let's make it happen. Okay, my dear friends, so input is obviously the common 0 0 0 1 1 0 and finally 1 1. But the output this time is gonna be 0 1 1 and 0. So can you figure out that what is the actual formula for that? That's interesting, right? So y is equals to a dot b plus b dot a, but we need to place the inverted thing like this. So it is using OR, it is using and it is using NAND, or let's say not. So it is using and, or, and not together. It's kind of the combo we have. Well, that's the first hint, that we can replace these three gates just by using one. Well, you are getting smarter, my dear friend. Okay, now it's time to learn the final gate that we are waiting. That is XNOR. So XNOR. I think you have already got the point of it. XNOR is exclusive not OR. Interesting name, right? So let's write its definition first, then I'll tell you its symbol. Exclusive NOR. I'm writing it simply, it's not OR as we know already. So what it is symbol. Its traditional symbol is something like this. We just need to make the thing like this, and this is gonna be responsible. This circle is gonna be responsible, as we can see here. This circle is gonna be responsible for our not part in exclusive or okay. Now what is symbol for IEC part? That is gonna be, just draw this one, write equals to 1 and put the circle here, and these are the inputs. So we have input and output. Well, that's it. Now what is its logical formula? Well, its logical formula is simple: a dot b plus b dot a, but this time we need to put the bar consecutively. That's the difference. I hope you can see the difference. I will show you what difference it makes in just a while. But let's first work on its TT, truth table. So we have A, B, and finally we have Y. So let's work on this thing, and we are gonna work on that and that. Okay, don't mind singing my. I'm sometimes singing while I am teaching so that I can entertain you. Okay, without wasting any time, I'm just going to put the results. 1, 0, 0, 1. Well, how we are doing that and using this formula, I think you already remember we have done it in previous section. That's why I'm not doing it. But surely if we do that, we're going to get anyway the same result. So it's something like fact type thing. We can calculate it logically, but we will going to reach to the same point. So I'm not proving that again and again. And what I was talking about, the XNOR and XOR, the difference is this bar point. As you can see, the bar is on A and then B, and in the next one we have the bar consecutively on both of them. So this is the difference. And with that said, congratulations my dear friend, you have completed all the gate revisions, and now we are ready to learn the next level of abstraction, which is how we can convert and reduce these many gates into just one. Well, how? Well, that we are going to see. We are going to use the NAND gate, and we are going to try to make all that gates. Well, how? I will answer that in the next one. So, till that time, keep pondering, keep learning, and keep enjoying. Take care and God bless.